Good day! In this video, we are going to do question 2C, part 1 and part 2 of the 2024 NCEA Level 2 calculus paper titled Apply Calculus Method in Solving Problem. Part 1 is chief. If you get part 1 and part 2 right, then you get excellent. So without further ado, let's do part 1. Part 1 sounds like this, okay? Okay, let's bring it up. A microbiologist is growing bacteria in a dish in a lab and monitoring the population of bacteria in that dish. After a certain number of days, the bacteria colony will have used up all its nutrient in the petri dish. At this time, the population will be at the maximum and it will then begin to decrease. When the microbiologist adds more nutrient to the dish, the population will begin to increase again. The microbiologists think that the population could be modeled by the equation Pt equal to t cubed minus 60t squared minus 768t plus 40,960, where P is the population of bacteria and T the number of days since the sample was prepared. What is the rate at which the population is decreasing on day 10? So we know that the population is Pt, okay, equals to t cubed minus 60t squared minus 768t plus 40,960. So to calculate the rate of change, we need to differentiate. So P1t, okay, differentiate is going to be 3t squared minus 120t minus 768. Okay, so the question asks you, what is the rate of change on day number 10? So to do the day number 10, we just need to substitute 10 into the t here, and then you put 3 10 squared minus 120 10 minus 768. Now what we're going to do, we're going to, so what we're going to do is that we are going to, let me see, something wrong, plus 768, sorry, there's plus 768, okay? So what we do, we're going to put in the calculator, 10 squared is 100, it becomes 300, and then 120 times 10 is 1 minus 1002, and plus 768, and if you calculate them, it's going to be minus 132, and that is an achieve, okay? So now we shall do part 2, which is an excellent part. So part 2 sounds like this. Okay, so we are going to read the question again, okay? So the first part is the same, okay? So the question is, use calculus method to determine the difference in bacteria population size from the time all the nutrient in petri dish has been used up to the time the microbiologist added the more nutrient. So this is the equation. So what we're going to do, we are going to differentiate, okay? We done it before. It's going to be 3t squared minus 120t plus 768. Okay, so to find the time, we need to actually make P1t equal to 0, okay? The first derivative equal to 0, so 3t squared minus 120t plus 768. Now we're going to factorize this. I've done beforehand, so it's 3t and t, and we're going to cross multiply. It's going to be minus 96 and minus 8, and you cross multiply t times minus 96 is minus 960, minus 8 times 33 is minus 24t, add them up is minus 120t, which is the middle. So when you factorize, you can do another way of factorizing, 3t minus 96, t minus 8, and that will be equal to 0. Now we are going to solve it. 3t equals to 96, which is t equals to 32, or t equals to 8, because t minus 8 equals to 0, so t equals to 8. So the two possible answers is t equals to 32 or t equals to 8. So to calculate the bacteria, we're going to put Pt, which is equals to t cubed plus minus 60t squared plus 768t plus 40,960. So when p equal to 8, okay, when t equal to 8, we're just going to substitute 8 cubed minus 60, 8 squared plus 768 times 8 plus 40,960. And now your job is to put in your calculator, and the answer is going to be, let me check, 8 is going to be 43,000 776. So please check the answers, and the answer for P8. The same thing we're going to do P32. P32 is going to be 32 cubed minus 60 times 32 squared plus 768 times 32 plus 40,960. Again, you're going to put in the calculator, and I done it before. It's going to be 36,684. So now the difference in population, you're just going to take this number here, 43,776 minus this number here, 36,684, and I calculated the answer is 6,912. So if you get it right, that's excellent in this paper. And don't forget to watch question 2D for another excellent question. So have a good day, everyone, and I'll see you soon.